we already completed the thermodynamics. We started the electrochemistry, hopefully, right?
Yes.
So now we go for the Nernst equation and its application. From that Nernst equation, they may ask definitely any one of the problems for your CP2 exam. So then electrochemistry, then corrosion, then 4 bias diagram, your second unit over, and third unit fully organic chemistry. Okay, right. So you know the Nernst equation. Nernst equation, you take any redox reaction, reduction and oxidation, for example, any n plus n electron to gives the product m, right? So this is a redox reaction. What is the free energy of this reaction? That free energy delta G equal to minus RT ln K plus ln of product by reactant, right? Product by reactant. RT ln product by reactant. So delta G equal to minus RT ln K plus RT ln product by reactant. So the K is the equilibrium constant. When it is the equilibrium, the reaction, the K is the equilibrium constant. So if you simplify this equation, delta G equal to, this is a delta G naught, that is standard free energy, delta G naught. Delta G equal to delta G naught plus RT ln product by reactant, right? Product by reactant. Delta G equal to delta G naught plus RT ln product by reactant. So we already know about it, the relationship between the delta G with the reduction potential. What is the relationship equation is there? Delta G with the reduction potential, any both related, any equation is there? In delta G with versus E, any equation is there? You remember any equation? Delta G versus E. Which means delta G equal to minus NFE. That you know, right? Minus NFE. Delta G equal to minus NFE. That is the only relationship is there, delta G versus E. Okay. So here we have to find the reduction potential. Therefore, the E is mandatory with the your free energy equation. So here you substitute, instead of delta G, minus NFE equal to minus NF E naught. This is standard free energy. Therefore, you can take a standard reduction potential, delta G naught. Instead of E naught, you take it plus RT ln the same product by reactant, otherwise reduction by oxidation, anything you can take it, right? So here both side NFE is the common, therefore you divide both side minus NFE. Okay, you divide both side minus NFE. So what we get is divide both side with minus NF. So therefore what happened? So minus NF E divided by minus NF equal to minus NF E naught divided by minus NF. Plus and minus only, therefore you can take it minus RT by NF into ln product by reactant, the same you can take it, product by reactant. Okay, product by reactant. If you cancel the common term all side, so what you get it, E equal to E naught minus, okay, if you cancel the common term or else you simplify, you convert ln into log, at the final equation what you get it, you substitute the gas constant value, R value, you know 8.314, and temperature, you take a room temperature, and the F value 96,500. So all the common term, you give the input and you convert ln into log, and finally you get it E equal to E naught minus 0.0591 divided by N. That means you convert all the constant, give the input all the constant, so 0.0591 divided by N equal to log of, okay, 0.0591 into log of reduction by oxidation, or else product by reaction, reduction by oxidation, NP. Okay, this is your Nernst equation. Okay, so E equal to E naught minus 0.0591 divided by N into log of reduction by oxidation, or else product by reactant. This is your Nernst equation. So here what is a N? N indicates how many number of electron transferred from reactant to product. Okay, 1 electron or 2 electron. For Daniel cell, for example, Daniel cell, what is the N value? You know that Daniel cell, zinc and copper, we connect each other, we get it 1.1 volt. Okay, from that we get 1.1 volt. So how many number of electron is transferred from reactant to product, or otherwise anode to cathode? How many electron shift? Anybody? We already completed Daniel cell. 2 electron. Yes, 2 electron transfer from anode to cathode. So therefore N equal to 2. Okay, N equal to 2. You know the standard reduction potential value is 1.1 volt. Okay, and they given the reduction in the oxidation concentration means you find it what is a reduction potential value for that concentration of solution. Okay, right. So this is a Nernst equation. So for that Nernst equation we can use to find the, what is the application of that Nernst equation, means to find the EMF of the cell. Yes, to find the EMF of the cell at any concentration of solution. If you vary in the concentration, we find the EMF of the cell, right? EMF of the cell, and to find the equilibrium constant, K equilibrium. When the reaction is, this is the reaction, right? When the reaction is existing the equilibrium, it attain the equilibrium. That means a reactant and a product, it attain the equilibrium, means that time we can calculate the K equilibrium. Okay, using the Nernst equation. And the next one is to find the Gibbs free energy. That's why this is the relationship, Gibbs free energy. Using the reduction potential value, we find the Gibbs free energy of the reaction. When we find the Gibbs free energy of the reaction, if it is negative means that is a reaction is feasible. If not, positive means that reaction is not feasible. That identification we identified based on the Nernst equation. Okay, one is there to find the EMF of the solution for any concentration. Okay, first application. And the second application to find the K equilibrium constant, because always the reactant is not converted into product, it attains the equilibrium. Okay, that equilibrium we find it. And third one is to find the free energy of the reaction, delta G, we find it. You write it. To find the EMF of the cell. Nernst equation application. Application of Nernst equation. Application of Nernst equation. Okay. Application of Nernst equation. to find the EMF of cell at given concentration. To find the EMF of cell at given concentration. To find the EMF of cell at given concentration. Second, to find equilibrium constant. See, first row you write it, you are sleeping. To find the equilibrium constant. And third one, to find the Gibbs free energy. To find the Gibbs free energy. To find the Gibbs free energy. So how we find the equilibrium, K equilibrium for the given reaction? You know the Nernst equation, E cell equal to V naught cell minus at the final value 0.0591. Otherwise, if the equilibrium not exist means take it. Okay, this is the equilibrium constant. How we find the K equilibrium, right? You know the K equilibrium, that is E cell equal to E naught cell minus 0. Or else 2.303 divided by NF into here RT into log Q. This is when you convert ln into log. Ln into log, you can take a 2.303. Other value is there. RT is there, NF is there, Q is there, equilibrium. When it exists in the equilibrium, the reactant and product is different concentration, it won't exist the equilibrium. It attains the same concentration means, so K equilibrium exists. Okay. So if Q equal to K, yes, when it attains the equilibrium, that time the concentration we can take it K. That is a equilibrium constant. So therefore, what happened here? Yes. Let's think about it. When Q equal to K, that means what happened in the reactant and product attain the same concentration. When it attains the same concentration means it won't transfer the electron from anode to cathode because it attains the equilibrium. Then how it transfer from anode to cathode? It won't transfer the anode to cathode. When the electron not transferred from anode to cathode means what is that cell? That is a dead cell. Cell we should not use it, we throw it. Right? We use the cell in our calculator or else clock, wall clock. So after some days, after some months, we throw it because there is no charge in that, which means it won't transfer the anode to cathode the electron. Therefore, that is a dead cell. Dead cell means what happened? E cell value is 0. That is a dead cell, right? E cell value is 0. That is reduction potential value is 0. That is called dead cell. Right? Dead cell. When it attains the equilibrium. When it attains the equilibrium, the E cell value is 0. There is no reduction potential value, therefore 0. So that time what happened? So therefore here 0. So 0 equal to E naught minus, as usual the other everything is there, 2.303 RT by NF into log Q. You write it everything, then you can interchange. So at finally what happened? Log K, that is instead of Q you write it K. Okay, log K equal to, only you find the log K only, right? Therefore log K equal to E naught cell into NF divided by 2.303 RT. You got it? This one. Just you simplify the above equation. You follow my notes one by one. You simplify the above equation. You need only the K equilibrium, right? Log K. So therefore, this minus, it comes to right left hand side positive. Therefore, you can keep the log K here. Already 2.303 there. So NF is there. So therefore, this one come denominator. This term come to the numerator. Sorry. Okay. Therefore, log K equal to E naught cell into NF divided by 2.303 RT. This is the K equilibrium finding. How we find the K equilibrium? So for example, if we take a Daniel cell, that means if you know the E naught cell means you find the K equilibrium. E naught cell is given in your tabular column. That is the reduction potential value they given. And Daniel cell, what is the E naught value? What is the E naught value? Daniel cell, 1.1 volt. That's why we discussed last class. Daniel cell, the reduction potential value of copper is 0.34 and zinc is minus 0.71. If you connect both, you get the 1.1 volt. So for Daniel cell, okay, for Daniel cell, the E naught value is 1.1 volt. Therefore, you find the K equilibrium for that Daniel cell. So therefore, what happened? Log K equal to 1.1 volt into, you substitute all the values. Okay, all the values. N value is 2. N value is 2. Then what is the K equilibrium? Okay, K equilibrium. You substitute here 2 and here 96,487, otherwise approximately 96,500. Divide by the 2.303 already is there, 2.303, and R value is gas constant 8.314, 8.314 and 298 Kelvin. So if you simplify what we get it here, okay, approximately 37.1288. This is a log K. If you want a K, take a antilog of this one. Therefore, K equal to 2 into 10 power 37. That is K equilibrium. Okay. Take the antilog of 37.288. You get the K value. K equal to 2 into 10 power 37. That is the K value for Daniel cell. The same you can use it for Daniel cell. Okay, Daniel cell, what is a delta G? Please find the delta G for this Daniel cell. What is the formula for delta G? Delta G formula. Yeah, delta G equal to minus NFE. Okay, here E is given, minus N is the 2 and F value is 96,487 and E value is 1.1 volt. Just you multiply, you find the delta G. Okay, delta G. 96,487 is the unit is joule. 1.1 volt. You know the 1.1 volt means 1 joule per coulomb, right? 1 joule per coulomb. Similarly, there 96,487 coulomb per mole. This is 96,000 coulomb per mole, and 1 volt equal to joule per coulomb. So here cancel everything. Finally you get it delta G in terms of joule per mole. Joule per mole. Okay. Joule per mole. What is the answer? And finally you get it approximately 2 point. Nearly.
Sir, where did we get the F value from?
Huh?
F equal.
What you are saying?
Where did we get the F value from?
Not delta F. The F, there is no delta F. F is constant. Faraday constant. 96,487. Only the delta E. Delta E only is the standard reduction potential for Daniel cell. 1.1 volt. 1 volt equal to 1 joule per coulomb. That is the meaning of volt, right? Volt means how much joule is there per coulomb. That is a volt. Therefore, you substitute. Finally, you get the maybe what is that? 1, 2, 3. So 1, 3. Yeah, 21,220 joule per mole. So we convert that one into kilojoule per mole, means 21.22 kilojoule per mole. Okay. Is there anything doubt?
Sir, that value it came in
Huh?
joule per.
Where?
Like, is there
E means the 1.1 volt, right? 1 volt equal to 1 joule per coulomb. Okay. So here per coulomb cancel. Here joule is there. Here per mole is there. Joule per mole. That mathematical calculation, you have to simplify quickly. So maybe you can take it here. I divide it into 2 parts. So magnesium. Okay, magnesium becomes magnesium 2 plus the concentration is given 0.001 mole, and the salt bridge is there, and it's become copper 2 plus. Their concentration is 0.001 mole. Divide and copper solid. So calculate the E cell value of the this cell, E cell value. What is the E cell value for the given E cell value? So you know the E cell value. E cell equal to E naught cell minus 0.0591 into log Q. Right? E cell equal to E naught minus 0.0591 divided by N into log Q. Right? This is the Nernst equation. So we have to find it, the E cell value. For E cell value, we have to know about the E naught cell. Right? For E naught cell, how we find it? What is the E naught cell? What is the E naught cell? E naught cell is the E right minus E left. Right? This is the cell representation. You know the cell representation, the left side is an anode, right side is a cathode. So therefore, E naught cell equal to E right minus E left. So E naught cell. First we have to find it E naught cell. E naught cell equal to E right minus E left. So E right, what it is? Copper. Right? E right is a copper. What is the reduction potential value of copper? That we know. What is the reduction potential value of copper? Yeah, 0.34 volt. 0.34 volt. and reduction potential value of magnesium. Sometimes they given, otherwise they won't given, means we have to take it. Okay, that is minus 2.37 volt. 2.37 volt. So now you find it, what is a E0 cell? 2.71 volt. 2.71 volt. That is E0 cell. E0 you can write it here. So actually you know the E left the reduction potential value is, yeah, somewhere I write it, means you continue here. Okay. Magnesium 2 plus divided by magnesium equal to 2.37, yeah, 37 volt, isn't it? So this is only we know, magnesium 2 divided by magnesium only, the reduction potential value is 2.37 volt. Why I put the minus here? Here oxidation is happened. Mg by Mg2 plus only they given in the calculation, but we know only the Mg2 plus divided by Mg. Hence, we take a minus symbol. Minus symbol. The reduction potential value of Mg2 plus divided by Mg is plus 2.37 volt. But here, oxidation is there. That means we can take a minus symbol and finally. Now you find it the E cell value. How you find the E cell value? Very easy. Yeah, you substitute. I continue here, okay? E cell equal to E0 cell value is minus or plus? Plus. How plus? Minus is 0.34 only, na? Minus.
Sir, minus plus.
So minus of minus plus. Okay.
Sir, it was minus then plus.
That's what, minus plus. So finally we write it plus 2.71 volt minus 0.0591. I continue here, okay?
Yes.
So this one, E cell equal to 2.71 volt minus 0.0591 divided by N. What is a N here? 2. How many electron transferred from reactant to product? 2 electrons. 2 into log of Q. Q is the, what is a Q? Product by reactant. So here product is what is the product here?
Sir,
That is a problem. We have to find the product, means they given the cell representation. You write the cell reaction, then only you know which one is the product, right? So cell representation, the magnesium divided by magnesium 2 plus, right? So magnesium and copper 2 plus equal to the magnesium becomes Mg2 plus copper. This is a cell equation, right? That is the cell representation. Now, what is the product? Mg2 plus is your product. That is the product, right? That is cell representation. See, this is a cell representation. Right side, left side. But cell reaction is magnesium copper 2 plus. Magnesium donate 2 electron to the copper, copper reduce and magnesium oxidize. So this is the oxidation. Okay, this is the oxidation. This is the reduction. Reduction, right? So here product is magnesium 2 plus. Reactant is copper. Okay, copper 2 plus. You got it? So now To know the product, otherwise we have to write it one more step, magnesium 2 plus, because they given only the concentration of magnesium only, not concentration of magnesium. Mg2 plus only they given. Therefore, 0. What is the answer? Divide by copper 2 plus. Otherwise, you write it 0.01 divided by 0.001. That's it. So you find it. So at finally, what happened here? 10 power 1 by 10, right? Am I right? What is the final? 10 power 1 now. 10. Log 10. Log 10 1. So only this value. That's it. You find it. You simplify this equation, you get it. So here whole term becomes 1. So therefore 2.71 minus 0.0591 divided by 2. That's it. 2.68. Approximately 2.68. Is the E cell value. E cell equal to 2.68. Definitely one question will be there for your CT2 exam, problem related. So I discussed how to find the free energy, I discussed how to find the K equilibrium, I discussed also how to find the cell potential, E cell. In that we find it already E0 cell. So everything is there. Okay, is there anything doubt in that problem?
Sir, will be given the cell.
Yeah, they given the reduction potential value.
Okay.
Only you need the reduction potential value. They given the reduction potential value in your question paper.
No, sir, will you be given the representation or the equation?
They given anything, either cell representation or else sometimes they given cell setup also. That's why when I given the first lecture, what is a cell representation? What is a cell setup? What is a cell reaction? What is a E cell value? Everything I given very clearly. Okay. Anything doubt? Very simple. Reduction by oxidation. Here. Magnesium 2 plus by copper 2 plus. Magnesium here oxidates. That's a product by reaction. In Daniel's cell, zinc 2 plus by copper 2 plus, right? Zinc 2 plus is oxidate, copper 2 plus is reduced, right? Therefore, right here. Here, right? Log of oxidation by reduction. Then only we get it the answer. Okay, sorry. Oxidation by reduction. Okay. So we finish the electrochemistry. Okay. Maybe if you have any doubt that we discussed, otherwise I move the corrosion. Anything doubt? What is the time? 120. 110. 120. Yep.